All right, so my name is Jered Dean, and I'm the director of the engineering design program at the College of Engineering and Computational Sciences, Colorado School of Mines. Most of my teaching is project-based design courses. So we run about 50+ student teams, and those teams have 5 or 6 students on them, 300 and some students a semester through multidisciplinary projects. So we have mechanical engineers, electrical engineers, civil engineers, environmental engineers, all working together on projects. And those projects come from industry, they come from research groups on campus, they come from the community, and then we also have some competition teams. We had a team working on wildfire runoff mitigation for Golden, Colorado, and trying to look at how and where you would put catchments. And so we have projects that really range the full spectrum. Our winner this year for the trade fair for the best team was a team that worked with partial quadriplegic, so on a downhill mountain bike. So they actually hot rodded a downhill, 4-wheel downhill mountain bike so this person could go down some of the trails. The students work with a client, work with professionals in the industry. They also have support in the faculty on campus, but we actually try and teach them the basics of project management, the basics of sort of design thinking, and how do you get your head around a difficult challenge and scope it. And then one of the things the students really struggle with is how do you balance sort of the textbook learning, there are these calculations I should probably run, with when you run them. And so that's another thing that we really work hard on. My favorite part, this is going to sound horrible, my favorite part is when the students break something. You know, they'll go through and they'll stay in CAD usually too long. We try and get them to be physical as soon as possible, but they'll design their pretty picture on the computer and then they'll build it. And my favorite moment is when it breaks, because they realize that no matter how hard you work in that CAD package, until you do real testing and really put it in front of users and really abuse it, you don't really know if it's right. There was a great experience at the end of this semester. I was walking through the lab, and all of a sudden I see this person with this pained look on his face, and I realize there's been a cloud of smoke released from the circuit board that he's been working on, no telling how many hours. And so I walked up and I said, "It's you know, looks like something interesting just happened here. Was that magic smoke I just saw that came out of there?" Yeah, I don't know. And so we started talking through what it might be, and I said, "So my guess is in your plan you ordered some extra spare parts and maybe an extra circuit board so that if something like this happened." No, I mean, the simulation worked. And that was like the most amazing learning moment there. You know, his first project out in industry now, when he gets ready to order that prototype, he's going to go, "Now wait a second, what might break? Because man, I remember when this had," right? And that's the goal of this project, this program. I think that there's more hope and optimism with the students, which is a beautiful thing. And so they sometimes come up with ideas that are outside the bounds and beautiful because they don't know any better. The flip side of that is I'm learning that a lot of design, and originally I was just kind of observing this, and I've been doing more and more reading, and I'm realizing that a lot of great design is just looking for analogies, or a lot of designers use a lot of heuristics, you know, just rules of thumb. And those things are hard to teach, and they come with experience. And so there are common problems that you run into that without that, you know, sort of graybeard experienced designer around, you end up spinning your wheels a lot. And I had never really thought through that until I started working with the students. I tell the students up front in the course that this is your safe fail. Once you get out in industry, there are usually consequences if something goes drastically wrong. And the worst that can happen here is you don't have a pretty prototype at the end of the semester, or your drawing set doesn't look so great, or your model isn't super impressive. This is where you get to try it, to put it all together, and see what goes wrong, and learn some of those really painful mistakes before your first assignment on your first job. So the thing that's most interesting about this generation coming out of school right now is so if the maker movement, right, is a big deal right now. And it's a beautiful thing in that it allows people to very quickly test ideas, build things, but it's a limiting thing in that really the maker movement assumes somebody else has given you the tools. So, you know, a lot of people will say, man, I can do just about anything with an Arduino, but what if, who made the Arduino, and then what if you need to go beyond the Arduino, right? Same with 3D printing, you know, oh, I got a MakerBot, I can print anything, but what if you need a bigger build envelope or you'd like a different material? And so I think it's slightly unique in this generation in that they have that whole maker movement available to them, and they can just hack amazing solutions together, cheap, from off-the-shelf stuff that would have been, you know, master's or PhD level research, you know, a decade ago. But then if you can take those students that have this amazing maker background and you can give them the fundamentals and you can give them the education to go, yeah, it doesn't worry me that I have limitations here because I actually know how to design one even better. This just gives me a way to quickly test my theory, and then I'm going to do something even better. That gives me a lot of hope. That's a pretty amazing thing to have. And a lot of the students that I'm seeing really have embraced that and have gone, well, yeah, I can pretty much make whatever I want, but I also have this education that allows me to dream bigger than that. I think if I had one piece of advice for students entering the workforce, it would be that it takes balance, it takes both. And especially design and engineering students are really typically driven students. And they sometimes fail to take into account and provide time for things like life, art, music, creativity. And to be a great designer, you gotta have both. If I had one piece of advice for people hiring this generation of engineers, it's that if they say, but why don't we? Say, show me. Usually they will show you something pretty impressive.
Cool.